Hello students, in last session we have a certain idea about the structure of benzene by means of chemical reactions, by physical properties, and a latest theory like a molecular orbital theory and resonance theory. Some practical evidence with the help of X-ray diffraction method, with the heat of hydrogenation method. So we can get the idea that in benzene there is a resonance phenomena and particularly aromatization phenomena that we have to observe. It means that benzene having a aromaticity type of character. Look, resonance is a different thing and aromatic is a different thing. All aromatic compounds having a resonance phenomena. But all the resonance phenomena, it doesn't mean the compound is aromatic in nature. For this purpose, or in other means, on paper, because practically evidence is by means of physical properties and chemical properties. Some evidence is definitely they give the idea about the benzene is aromatic in nature or such a compound is aromatic in nature. But on paper or on a theoretical view, how we can judge the compound is aromatic in nature or not? For this purpose, we have to continue with one more important rule is called as Huckel's rule. Okay, this Huckel's rule is applied either the compound is aromatic in nature or not. So Huckel, on the basis of molecular orbital theory, mind well, on the basis of molecular orbital theory, Huckel's predicted that electrons in, mind well, the first condition is your particularly compound is cyclic in nature. In cyclic conjugated, another condition is a conjugated Pauline system. What is the meaning of a conjugated Pauline system? Cyclic Paulines having a alternate single and double bonds containing 4n plus 2 pi electrons. Right? So these are the condition for a conjugated Paulines, and these Paulines having a 4n plus 2 pi electrons, where n is equal to either 0, 1, 2, 3, etc. They are completely delocalized. So this makes this molecule particularly stable, right? So all such compounds are called as an aromatic compounds and have a chemical properties altogether different from the other cyclic unsaturated compounds, which do not contain 4n plus 2 pi electrons. Some compounds are cyclic in nature. Definitely they are cyclic in nature. They are unsaturated too, but they do not have such a type of conjugated Pauline. Some compounds having a conjugated Pauline too, but they do not release any type of energy. So it's resonance energy they do not release. So they are not particularly aromatic in nature. What are the necessary and sufficient conditions for a molecule to be aromatic are? So on paper, how we can predict or forecast our compound is aromatic in nature or not? So first conditions, it should have a cyclic, mind well, non-cyclic compounds, there is no particularly aromatization phenomena that we have to observe. Cyclic cloud of what? Delocalized pi electrons. Delocalized means they are not particularly at a stable positions or they are local in nature, right? Pi electrons above and below the plane of the molecule. It should be planar. It's the most important conditions. Why it should be planar? Because this is due to the reason that complete delocalizations of pi electrons is possible only if the ring is planar. So to allow a cyclic overlap of p orbitals. So it should contain a 4n plus 2 pi electrons. So these are the main three conditions: cyclic, planar, 4n plus 2 pi. So if these they fulfill, any compound who fulfill these three conditions, it means that it's aromatic in nature. A molecule which does not satisfy any one or more of the above conditions is said to be non-aromatic. For example, in the case of JEE and NEET, I have to demonstrate third category is called as an anti-aromatic. So compounds which can be classified under aromatic, anti-aromatic and non-aromatic. Now we have certain applications of a Huckel's rule. How we get the idea that our compound is a aromatic in nature or not? So for this purpose, we have two applications of Huckel's rule, like a monocyclic system. The meaning of monocyclic system means your compound having a single cycle, means one cycle. So in the light of above rules, any planar, okay, or cyclic system containing how many electrons? So in this case 2, 6, 10, 14, 18, because we have to put the n is equal to 0, then 2, n is equal to 1, then 6, n is equal to 2, 10, like that. So this amount of pi electrons and having a single cyclic pi electron cloud, so all the carbon atoms in the ring is aromatic. So let us now we test the validity of this rule with the help of this monocyclic system. For example, look, presently this lecture is mainly concentrated for the purpose of JEE as well as NEET. Okay, one compound is like that. Okay, so the name of this compound is what that we have to discuss in our prior session too. This is cyclo in nature. Yes, definitely it's a cyclo in nature. Okay, how many carbon? 3 carbons. So cyclo and propene in nature. Yes, so cyclopropenyl, because it's a cation in form. So cyclopropenyl cation. Look, this compound is planar in nature or not? So sp2 and here carbocation, so definitely sp2. So sp2 is a planar in nature. So our compound is definitely planar in nature. How many electrons? So cyclic, first conditions they obey the cyclic nature, then planar, and then 4n plus 2. So how many electrons? Put the value. This is 2 pi electrons. If we value is 2, so it means that our compound is aromatic in nature. Mind well, there is no resonance, there is no particularly benzene ring, so it's a non-benzenoid compound. So such a type of non-benzenoid compounds are also aromatic in nature. While in this case, if we studied the compound is like that, okay, but mind well, it's a same compound, but it's a anion in form. So it's a cyclopropenyl anion. Our compound is planar in nature. Yes, definitely planar in nature. But how many electrons? Because this 2 pi electrons is also taking a part in your system. So 2 plus 2, so it's 4 pi electron. So 4 pi electron means it's a not aromatic. Another example is like that. For example, if I having a structure like that, okay, H plus. So it's a cyclo in nature. Yes, definitely cyclo in nature. So it's a pentadienyl and cation. Okay, it's a planar. Yes, definitely it's a planar, because sp2 in whole system is sp2. Okay, number 2 is how many electrons? So 4 pi electrons. So 4 pi electrons means it's a possible. No, 4 is not considered in this Huckel's rule. 4n plus 2 pi electrons, right? So it's a non-aromatic compound. One more example, same example, but not in a cation form, but in a anion form. Same, anion means extra electrons. The name same, cyclopentadienyl, but anion. Okay, how many electrons? 2 plus 2 plus 2 means 6 pi electrons. 6 planar. Yes, definitely it's a planar in nature, and 6 pi electrons, cyclic, planar, and 6 pi. So they fulfill all the conditions, all the above conditions. So it's a aromatic in nature. Lots of particularly examples that we have to studied about the validity of this rule. One more example is like that. Mind well. Okay, it's not a benzene. Okay, fine. So, okay, it's like that. It's like that. Okay. So, 2 hydrogen. Okay, the name is like that. Cyclo. How many carbon? Hepta. 7 carbon. So, cyclo, hepta, triene, 3 double bond, triene. But this compound, because here the hybridizations is different, so this compound is non-planar. If they not fulfill the first conditions, okay, but 6 pi electron, okay, 6 pi electron, but not spread over the entire ring, so it's a not aromatic. Next one, one more example is like that. Same example, okay, same example. But the example in a carbocation form. Name is like that. Cyclo, hepta, trienyl cation. Other name is a tropylium cation 2. It's a other name of this compound, tropylium cation, right? This tropylium cation is a planar in nature. Yes, definitely it's a planar in nature. Okay, having a 6 pi electrons. Yes, 6 pi electrons spread over the entire system. Yes, because there is a resonance delocalizations of all pi electrons. So our compound is aromatic in nature. So compound is aromatic in nature. One more example, same example. Okay, fine, mind well. The same example which can be given, but in a carbanion form. Same name, cyclo, hepta, trienyl, but anion form. But it's a non-planar compound because the hybridizations is here sp3. So it's a non-planar. Okay, so game over for what? They obey the 8 pi electrons? No, because they do not obey Huckel's rule regarding to the aromatic. So it's a not aromatic. Same way. Another example is like that. Okay, the name of this compound is cyclo, octa, 4 double bond, so tetraene. But this compound is non-planar. Why is the non-planar? Because it's a top type of structure. So it's a non-planar. If non-planar and 8 pi electrons, so not aromatic. Clear? One more example is like that, but this example, mind well. It's different then, okay? It's a totally different because it's a octahedral, octa angle. So cyclo, octa, tetranyl dianion, because it's a dianion. But it's a planar in nature. Definitely it's a planar in nature. 10 pi electrons spread over the whole system. So this compound is aromatic in nature. So this is about the monocyclic system. Now we move to the another point. Another portion is called as another system is called as an polycyclic system. Number 2, it's a polycyclic compounds. Polycyclic compounds. So what are the called as in polycyclic compounds? The polycyclic compounds means they're having a more than one ring. For example, in the case of more than one cycle, right? So these are the compound. The name of this compound is a naphthalene. The name is called as a naphthalene. Okay. So in this case, one more example. Clear? So it's a anthracene. This compound is naphthalene. Okay, so here N is equal to 2, completely 10 pi electrons, planar in nature. So definitely it's aromatic in nature. Same way here, N is equal to 3. You have to put the N is equal to 3. So how many? 14 pi electrons and aromatic in nature. Same way, it's another isomers of this anthracene which can be drawn in this manner too. Clear? Fine. So in this case, the name of this compound is phenan 3. So cyclic in nature, yes. Planar in nature, yes. Completely conjugation, yes. And how many electrons? It's a 14 pi electrons due to 3 rings. So it's a aromatic in nature. So they all are aromatic in nature. Now third one, and it's the most important for JEE as well as NEET point. So it's a heterocyclic compounds. The meaning of heterocyclic means in your cycle is not a homocyclic but one heteroatom like nitrogen, sulfur, oxygen, which can be, it's a part in your ring. So heterocyclic compound such as, for example, if I give one example, or we start with the example like that. So nitrogen is a heteroatom. Okay, fine. So the name of this compound is pyridine. Another example is furan. One more example, but in case of oxygen, sulfur, so it's called as a thiophene. Next one, so it's pyrrole. So what you observed in this pyridine compound? In pyridine, each of 5 carbon, 1, 2, 3, 4, 5 sp2 hybridization carbon atoms, and the sp2 hybridized this nitrogen atom have a p orbital is a perpendicular to the plane of ring. So each of these atom contributes 1 pi electrons, thereby producing a single cyclic pi cloud. So they are having a 6 pi electron because 2 plus 2 plus 2, at that time it's a perpendicular in nature. Okay, so the lone pair of the electrons of the nitrogen atom is present in sp2 orbitals, which being in the plane of the ring does not contribute towards the aromatic ring. So that's why 6 pi electron and our compound is aromatic in nature. But in contrast, in case of furan or thiophene or pyrrole, one of the two lone pairs, okay, of electron on the sp2 of either oxygen or sulfur or nitrogen is present in p orbital perpendicular to the plane of the ring. So consequently it contributes 2 pi electrons, while the other 4 p orbitals of 2 double bonds contribute 1 pi electrons each, thereby bringing the total 2 plus 2 plus 2 means 6 electrons. So thus all the 3 5-membered heterocycle like furan, thiophene and pyrrole having a single cyclic electronic cloud containing all having a 6 pi electron, 6 pi and 6 pi. So they are aromatic in nature. So all these 3 are aromatic in nature. One more category is like that. It's aniline 2. It's which cannot be discussed in our book. Completely conjugated monocyclic polines. For example, if I give example is like that. So it's called as in 4-enulene. 4-enulene. So enulene is a different concept. The other name of this benzene is also called as in 6-enulene. The name is enulene. What is the meaning of enulene? Same way, completely conjugated monocyclic polyenes containing an even number of carbon atoms are called enulenes. Their general formula, the general formula of enulene is like that: CH double bond CH n times, right? So these where n is equal to what? N is equal to 2 or 3 or 4, like that, etc. So they are enulenes. So enulenes is also particularly considered either the compound is aromatic in nature or non-aromatic in nature or anti-aromatic in nature. So this is all about the Huckel's rule, which can be discussed in our book, but today further discussions with the help of various examples that we have to given in our today's lecture. Thank you very much.